welcome to this Helix webinar series. Today's session is focusing on Ask the Experts, and this is going to be covering BMC Helix Discovery. We've deliberately left it very ambiguous because there's a lot of questions that come from any of the webinars that we do, blog posts, and sometimes support questions that come directly to a customer to support. So we feel that this is an opportunity for you to speak with us live. Thank you to those that have already given us a few questions that were pre this event starting. We will get through some of those today. Some we do have too many, so we may have to take those offline and send them separately. But we want this to be an interactive session. So at any point, if you have any questions, like with the webinars, if you use the Q&A section of Zoom, put your questions in there and we will take those questions as and when we go through today's event. It's going to be for 1 hour maximum. If we do have any further questions that we don't get to, we will take them away as a team and we'll put them into the Q&A blog post. So with that, I'm going to get started. We're not going to do the full introductions because there's many of us today. We've got 8 on the panel. So we're fortunate to be joined by product management, product development, and also support and Premier support. So we've got a lot of experts here to help you today. So welcome and thank you to our panelists for joining. So if we can get started, and Andy, if we can move to the next slide. We did get a question that came in prior. So this was the first question that came. Searching shortcuts like DA, host dot and VM dot are very useful in quickly narrowing a search to do a specific node type. Also, is there a list of these shortcuts for other node types that can be shared? So I'm going to open that up to our team. I don't know who would like to take that first question.
So I'm happy to take that question because I think Duncan's going to be doing the lion's share of the work today. So I'll take this one because it's easy. So yes, they are very useful shortcuts. I don't know whether everyone on the call is aware of them in the first place. So it's good to share it. But this refers to the interaction that you'll be able to do in the Discovery UI. On the top right-hand side, there is a search box, which is a very common thing to use. And if you search, you can use it to search for any string. So you can put a search term in there and hit return. You'll get very quickly get a large amount of data found across all node kinds. But often you would like to restrict it to a particular node kind. And this is where these shortcuts are quite useful. So instead of searching for a host name and then getting a hit across a whole bunch of node kinds, you could just go host : and then the host name. And that will restrict your search results to only the host node kind. And there is a bunch of shortcuts like that are in the user documentation. We can post a link to that in the chat. And there are a variety of shortcuts like BAI, SI, host, VM, CSI that should be self-explanatory, but if not, then have a look at the documentation. And if you want to see a demonstration of that, I would imagine at some point Duncan may be doing a screen share and we might be able to sneak in a little demo of one of those later. Is that okay, Duncan?
Yeah, I can show it now. Maybe I should show it now. We'll find out whether the sharing works now. So, hello everyone, I'm Duncan. I'm the architect of Discovery. As Andy says, I expect I'm going to be answering many of the questions, but I will attempt to share this. Although Zoom is making it complicated. What are you telling me?
I can confirm I've lost the sharing, so I think it's heading your way. Oh dear, I can see myself.
I think I'm now sharing Zoom back at you, which is not helpful. Come on. Okay, right, now I'm hopefully sharing a Discovery screen. So yeah, this is what Andy was just saying, which is that in the quick search, hopefully if you've used Discovery, you have noticed the quick search because it's one of the main navigation things. And it does give you a little hint in the tooltip, if you can see that, but it says you can try host : a host name. But it does more than that. So I thought ahead of this question. So if I search for Apache, this is a pretty common term, and you can see I can find many, many results that involve the word Apache, which is fine. I can then search through these. But if I knew I wanted a particular type of thing, and in fact, in this case, host was not one of the things in the list. But imagine I was only interested in software instances. Well, I've wasted a whole load of time. And sometimes if you search for things like IP addresses, they appear a lot in a lot of places, and therefore it can take a while to find these things. So you can, in here, you can type any node kind. So I can type software instance : Apache, and that will find only software instances. So now you see I haven't got the list of kinds, I've got the list of only software instances. So any node kind at all that is defined in the system taxonomy, you can search by typing the node kind, a colon, and the thing you want. But things like software instance are things you want to type a lot, and it's quite long and quite annoying, and it's easy to mistype. So there are some abbreviations. So SI colon is equivalent to typing software instance. So if I say SI colon Apache, I'll end up with the same list because that's an abbreviation. And similarly, you've got VM for virtual machine, BAI for business application instance. There's a whole bunch of these which are in the documentation. So we'll provide a link for that, but it's just a shortcut. Another possibly less known thing is if I want to have a list, for example, of all the virtual machine nodes, then I could go to explore data and figure out where in this list of things virtual machine might be, although it is. But I could, in fact, type VM and a colon. And what's the search term? Well, I won't give a search term. And that, therefore, will find me all the virtual machines. So you can use the quick search to search for all nodes of a particular kind just by typing the node kind and a colon, or one of the abbreviations for the node kind and a colon. So this is possibly a slightly hidden feature, but it's very handy as a speed of navigation device.
Thanks, Duncan. Eric, I believe that was your question. Does that answer what you needed, if you can hear us? You might need to take yourself off mute.
Well, I think we should move on.
Okay.
It's not a very interesting. It's a little trick topic, but it's not a very interesting thing to discuss further, I don't think.
Okay. Andy, do you want to bring back the slides again? Perfect.
Almost immediately. I'm there. There's the.
And I was just looking at the documentation that you were describing, Duncan, since we're here. You can see the information about that quick search, but I'll go back to the slides. So that was that one. Moving on to our next pre-submitted question. A fairly involved one, perhaps, and guess what? Duncan's probably the one to answer it. How do removal groups work in TPL?
Yeah, so this is an interesting topic. We were talking about this before the meeting started in terms of our planning, and we could probably spend the entire hour talking about removal groups and how they're used and how they're implemented, but I'll try and be more brief than that. So for people who don't know, well, I don't know who's in the meeting. So in Discovery, there was a language called TPL or TEPL, which is the programmable part of Discovery, and our TKU patterns, our knowledge updates contain a lot of TPL code. You can write your own TPL code. If you've no idea what any of that is, then this question is not for you. So I'm assuming that you know what TPL is and the kinds of things you can do with it. And well, it's very common in a pattern that you do some kind of discovery activity and you find a collection of things. And I'm being vague about what type of things they are. So these might be databases, they might be software components, they might be information about deployed elements inside something custom. And so what happens is the first time the pattern executes, it says, oh, I found 10 things. It creates 10 nodes for those 10 things, or 10 relationships for those 10 things. And then the next time you scan, you find only 8 things. And maybe it's all 8 of the things you had before, but 2 of them have now gone. Or more interestingly, maybe you find 8 things and 6 of them are ones you had before, 2 of them are new and 4 of them have gone. So the question is, how do I then get rid of the things that were previously done the last time the pattern executed? And this is where removal groups come in that what you can do in your pattern, and this is where I should have prepared, but I didn't prepare enough, but there's an example here. This is one of our TKU patterns, which is really quite complicated. So I don't want to get too stuck into the details of it. But if I search in here for this example,
grab the sharing, Duncan.
What's that, sorry?
You might want to grab the sharing if you're.
Oh, I thought I did. Sorry, I will try again.
You now have the sharing.
Yep, I know. Sharing. and I'm not, Zoom is determined to share the thing I don't want. There we go. So this is a bit of our knowledge update standard pattern for Apache Kafka. Just a thing I happen to pick. There's nothing special about this one. It's just an example one where it is creating a relationship in this case, and it's creating a detail node, and it's putting them in a removal group. So what this means is that each time it creates a detail, they get put in a removal group, which means that next time it triggers, if it doesn't create the same collection of things, it will automatically remove the ones that it created last time. I picked this pattern because it's got a few interesting things in it that are worth pointing out to do with removal groups. And then I think there's part of the question was around, okay, how is it implemented behind the scenes, and can I see what's going on with this? And I'll come to that in a second. But so the point of this is to say that these details, and in this case, it's a slightly more complicated way than it could be. Let's find another. Here's a better example. Where's the good example that I had? Here we go. Yeah, so here's an example where it is creating a node and immediately puts it into a removal group. So this is the classic example of you collect some things, you put them in a removal group, and then next time the pattern triggers, if you don't specify the things again, they get removed. Now, if you were looking carefully, let me find again. This is a call called suppress removal group. Now, what this is that in general, you trigger your pattern, you do some discovery, you say the things I found I put in a removal group, which means that next time if I don't find them, they get removed. But sometimes you do a bit of discovery, and sometimes that discovery just fails altogether. So you say, tell me all of the details, and rather than saying there's 10 details or 2 details, it says error, you didn't get any details of any sort. And in the face of that error, you probably do not, in fact, want to remove the things that happened last time, because it's quite possibly a transient kind of an error. So you have this thing called suppress removal group that says, okay, actually don't in this execution, do not remove the things in the removal group. So that's one of the things that you can do with a removal group, is to turn it off just for one execution so that it doesn't happen. The other thing also appears in this. If only I could type. Anchor removal group. The other thing that happens in here is a tricky thing that people possibly struggle to understand, which is that when you write a pattern, you trigger on a node. And there's 2 basic kinds of things you might trigger on. You might trigger on a directly discovered data node, like a discovered process, or you might trigger on a stable thing like a software instance. Now, if you trigger on a process, then it's not meaningful to talk about the next time I trigger on the same process, because each time you do a discovery, you get a different set of processes. So that means you can't use a process as the thing we call the anchor for a removal group, because a removal group remembers the things that came from that particular node. Well, each time you scan, you get a different set of discovered processes, so you can't anchor on those. So if you do trigger on a DDD node, like a discovered process, you have to pick another thing to anchor based on. So this is code that it's got a Kafka software instance, and it's saying anchor this group on this software instance. So that means that basically anything that I previously said was associated with this software instance, and next time it gets removed. So maybe that all sounds very complicated, but it possibly becomes easier to understand if you see how it's implemented. So the way it's implemented is that within the system, there are relationships called inference relationships. And this is what drives the provenance display. So in fact, if I go and find, let me pick a random software instance, maybe I've even got it. I'm not sure I've actually got any Kafka in. Have I got a Kafka software instance? No, typical. Okay, never mind. Let's look at a Tomcat. I've definitely got some of these. So if I pick a random Tomcat software instance, then if I look at one of these and say hide the visualization, don't want that, and say show the provenance, this provenance feature, which shows you where did data come from. So this is able to tell me that these values have come from particular places. Now, the way this works is that behind the scenes, there are relationships within the data called inference relationships that say, where did the data come from? And it's on those relationships that the removal information is stored. So I'm going to do a search. We'll put this in the in the meeting transcript so people can see this. But I'm going to do a search to say, find me all the inference relationships I've got in this data, because I don't have a lot of data here, and show me the information about it, and including that this is a thing that is going to show me what is what's in the inference relationship. But if I run this, then so I'm looking at a bunch of relationships. Now, there's some interesting data stored on the relationships, which is the identifier here. That identifies the pattern. And, well, sometimes it's not a pattern. So there's a flag saying whether it's a pattern or not. Keys, this is the thing that drives the provenance display. But the interesting thing here is this section saying removal group, and you can see a bunch of them are not set, and that's because these ones didn't use a removal group. But if I sort by this, I can, for example, find LBR group, which is the name used in the pattern. So these, you can see this is something to do with the F5 big IP load balancer pattern. And you can see that this is telling me the nodes that have been put into this relationship, this removal group for load balancers. So if I look at this, this is a load balancer pool, and I know that that now is in a removal group that is maintained by the load balancer pattern. So you can mine this information if you. We don't have time to dig into it now, but you can use the query language. You can be looking at a node and say, okay, what removal group is this node in? And queries like that, if you want to know. Why would you want to know? Well, all of these are things that are put there by TKU patterns, and probably you have no reason to know or to care about that. But if you're writing your own patterns, then maybe you do want to be able to validate, okay, this thing should be in a removal group. Which removal group is it in? Or is it correctly in a group? Or did I forget to put it in a group? So you can answer these kinds of questions by mining the inference relationships. So I'm hoping that some people actually followed that, but it's quite deep and technical. And if you're not a TPL developer who writes your own code, well, it's all, you have no reason to care, but hopefully maybe that answered the questions.
Thanks, Duncan. Andy, before we go back to the slides, I can see we've got a couple of questions in the Q&A. James, if you're still there, do you want to come off mute and ask your question? I know Andy's going to be able to answer it for you. Can you hear us?
Yeah, hopefully you can hear me. So it's really questions. So we've got over 1,000 models, which were all built using Start Anywhere mapping with automatic updates. One of the challenges we've had is almost managing the drift and the automatic updates, which has resulted in us having to shift quite a lot of them to static models. As we try and exclude stuff, they keep coming back. So we're just really after some best practice around how best to model, kind of maintain those models.
That's a reasonable question, and I thought it'd be useful for us to answer it live, because I'm sure there'll be some discussion amongst the panel on it as well. I mean, it's quite hard to answer in the abstract, because obviously we're not going to look at your specific models, but the kinds of challenges you're referring to, I think, are known. There's a few things that may or may not apply in your situation, but in the past, in my experience, I've seen a few things that have resulted in potentially more nodes being added to a SAM model over time than you would like. I mean, sometimes it's just a nature of the software you're modeling, but something I've seen quite frequently is that there's a tendency or an understandable desire to when you're starting the modeling process, to start your modeling and therefore your visualization and therefore the model from the hosts or a set of hosts. And when you look at a visualization of a host, it shows you all the software that's running on that host, whether it's interesting to you from a service modeling perspective or not. And what can happen, and what's happened in some situations, is the service model has been created with the host or hosts in it with all of their software, and then software that's related to that software gets pulled in the future, but it's not related to your particular business service. So a best practice I've seen people adopt successfully is, if you are starting from a host, by all means do, but then step on another hop further and visualize the particular software instances that are relevant to your application, to your business service. Because that will then, it will still show you the host that it's running on, but it won't show you all the other unrelated software that is also running on the host. And because that's not included in the visualization, it won't be included in your model, and it shouldn't be then. It can limit some of the noise that you might get added later. I don't know whether that's something that may be driving some of your experience, but possibly or possibly not. Another capability which judging by the way you asked the question, I think you're aware of, is that it is possible to add do not follow rules in Discovery that will tell the system, as the name suggests, to not follow a particular relationship from a particular kind of software thing to another kind of thing. Is that something that you've made use of?
To a degree, yes. Yeah.
Yes. It's also true that there are some pieces of software where we might choose out of the box to limit whether Discovery will follow those relationships. Has that capability helped in some regard, or is it? Oh, maybe it'd be useful actually at this point for you to give a concrete example of a kind of drift that you saw that was problematic.
Good example. Bunch of standard agents sitting on a server, be it Snow, security tools, whatever it may be. Remove them. Week later, pop back despite being excluded.
When you say remove them, so okay.
So if I can chip in here, if agents are being in the model at all, that's probably a sign that, as Andy says, that the model started from a host that started to, and therefore is by default including everything on the host. Whereas if you start from something other than the hosts, then it can more closely narrow it down. If things are being removed, if you explicitly remove something from a model and then it comes back, well, I hope that means that it's not literally the same node that has come back. It might be, it might seem to be the same one, but it's probably that it actually got removed and then has come back, because the system remembers the things that are removed. There's no reason why it would forget, I don't think. So just to start from something that is not a host certainly helps to remove all of these agent-like things. The other thing that, the other feature that we have that is potentially helpful to prevent things, it would not prevent the agents being added, but it is very common that agents are then connected to some kind of server for the agent, and that then pulls in the whole world because all of the agents are connected to the same server. So something that the system tries to do automatically is to identify things that it thinks are shared by multiple models, multiple different services, and automatically not follow their relationships. But you can actually, in a visualization, in a service model, you can right click on a node and say, treat this one as shared. So even if the system has not decided it's shared, you can force it to treat it, which can help to reduce some of this noise. The other thing to say is that this is definitely a challenge. That the SAM service modeling is very good for certain kinds of services and less good for others. And something we didn't really communicate, at least not verbally in this call, is that on the whole, in this meeting, we want to talk about current features and not futures. We're not going to talk about roadmap items, things coming, because, well, this is not the time for that. However, we do want to improve the product. And so if you have concrete examples that can be given to us, not live now in the meeting, but offline, if you could give us real world examples, we would love to see that, because we would like to improve these features in the future. And to do that, what a SAM service model is trying to do is it's trying to use its intelligence and its knowledge about the world to automatically do the right thing for you. And just like any kind of AI training, we need real world data in order to base that on. So if you can help us, then we'll be able to help you in return in terms of consider future features to allow that to occur.
Okay.
But does anything that we've said potentially resonated, might match your problem scenario?
I think definitely we would traditionally start with a host. I think that's probably 99% of the time where my config team would have started a model, because that's what they're going through, because we're doing a lot of work around decommissioning, and normally it tends to start of server A, B, C, and then work backwards from there, versus not necessarily knowing what software is on those servers. So yeah, it's definitely see.
Yeah, so it might be worth when you're next doing a model like that, if you start from the host, it's fine. Finding a set of hosts is very natural because that's what you're searching for. But then if you can step a step further and then click on the software or software instances that are relevant to your particular service and visualize those, that can potentially be a good step.
Okay, thank you.
Appreciate the question. Thank you very much.
Thanks, James. Thank you. Adam, I can see you're going to answer Eric's question. Do you want to take that question live?
Yeah. So I'm Adam, one of the developers on the Discovery product. The question is around, there's removal groups that Duncan demoed that use names. So you can have multiple removal groups. As Duncan said, there's a default removal group typically anchored to the trigger node. If it's a DDD node, then yeah, you probably need to pick a different anchor. But you can have multiple removal groups with different names. Really, you only need to do that if you want to manage the nodes that you're creating on a different kind of life cycle. So with Duncan's example, you're creating the load balancer and you've got the load balancer members and everything else. Typically, when you look at the load balancer, it's got so many members, and then that number changes every time you look at it. That's just a group. But for some kinds of devices or software, you might well have different kinds of related things. So the members and some other subcategory of data, it's a bit hard to explain without a good example, that kind of exists on a different life cycle, or that you need to manage separately. So for example, you run a command to find out how many related things there are, then you run another command to find out how many of another kind of thing are related. You want to manage them separately because either of those commands could fail. And if it fails, well, you probably want to leave the removal group alone. You don't want to, you see what I mean? There's kind of half the data from one and half the data from another command. So in that case, using two removal groups just insulates you from any error conditions, and suddenly it removes all of your data because you couldn't confirm that it was there. But that's really the only reason to use multiple groups. You can put any kind of node into a removal group as well. So if you're creating details and software components or databases or any kind of subnode, you don't need separate groups for different kinds of node. They can all just go into one group if they're all related to the same thing, and you can create them all in one kind of batch, if that makes sense. So yeah, there's no requirement for using named groups or having multiple removal groups, but sometimes it's a good way to separate things out to just deal with error conditions in a cleaner way.
Yeah, the other thing, this is what I said, that we could easily spend the entire meeting talking about removal groups. The thing that's key to think about removal groups is that they are anchored on a particular node, and normally that's the node that the pattern triggers on. But the thing is, so back to this load balancer example, it's not that there's one removal group for all load balancers, that the pattern is triggered on a load balancer instance, I think. So that means that particular load balancer instance, that has a collection of load balancer pools and a collection of load balancer members and so on. And so anything that was for that particular load balancer instance that was previously inferred and now has not been, will be removed. But any other load balancer instance, well, that's also got the same group name, but those ones are different because they're anchored on a different one. And this is where the relationships, seeing how the inference relationships work, is as simple as saying, well, starting from the trigger node or the anchor node, there's some relationships of type inference to other things. Well, those are the things that are candidates for being removed by the removal group. And so the naming of removal groups, it's easy to imagine that you need to name your removal group something unique so you don't remove the wrong ones that belong to some other trigger node. And that's not how it works. It works in the context of the trigger.
Okay, that does help, and that's exactly what I was asking or getting at with that question, is multiple load balancers in the environment. When you look at the surface of the removal group name, they all say LB group. but that's what I was trying to understand.
Yeah.
Is there a singular group that all the inferred nodes and relationships get dropped into? But to your point, it's per device. Is there a way to then tell, okay, this group, this specific instance of this removal group is linked to this triggering node?
Yes, because it's the inference relationship that I showed. I don't want to get stuck into showing it again, but I'll show it later. So that query, it finds the inference relationships, and well, you can look at the ends of the relationship. Well, one end is the inferred node. So in the example I gave was a load balancer pool. The other end is the anchor, and so that anchor that tells you the answer that you want to know.
Got it. Okay, that's very helpful. Thank you.
Thank you for your question, Eric. I see we have a question from Jose Louis. Adam, you answered the first part, I think. So if you want to bring the context together, and Jose, if you want to come off mute and speak to us live, that would be great. Adam, I'll start with you.
Yeah, it's a question around identifying appliance devices, particularly coming from OVAs and things. And really, we've got a little bit more into the detail about some of these devices. They're kind of provided by a vendor and they don't have a way to add users, and SNMP isn't enabled and all the rest of it. They kind of do the job and that's it. The way Discovery works, it's looking for devices on the network, and we want to try and identify what kind of device it is. And we do that by looking for some kind of unique ID, and it doesn't have to be something we can get with a credential. Often, we can scrape a web page, or we can look at a telnet header or web header or something like that to work out, oh, it's this kind of thing, and then we know how to approach it. So if we can't log into it with a user and we can't query it with SNMP to get hold of its object ID or its descriptions, then we're really back to, well, how do you talk to it? If its only interface is, say, a web interface, well, is there anything unique about that web interface? And the product has a lot of web plugins. We add them in the TKU every month for that kind of thing, where we can look at the web interface or a REST API or something, and even without a credential, often there's enough information for you to have an idea, oh, this is this kind of device, this is how we would approach it. So they shouldn't be invisible, but maybe we can't discover it out of the box because it's another thing we don't have a way of identifying it. So obviously, when you log into something where you can query something with SNMP, they're fairly generic mechanisms that work for a huge variety of devices, which is why they're a great way for us to identify things. But when you can't use those, and it's then something very specific to that particular device, especially ones where they run web interfaces on non-default ports and things like this. So even a web request doesn't work. You have to know that you've got to look at a special port. We can do that, but you've kind of got to know that you need to do that up front. That's why, maybe for this specific kind of device, then that's something we'd have to look at.
Yes. The question is basically you need the collaboration of the provider in this kind of products, because you don't know exactly the content, you don't know exactly the operating system and something like that, because normally it's not a standard operating system, it's a mixed or something like that. And it's very difficult for us to discover this kind of product because we don't have the collaboration of the provider. In this case, for example, a specific case of Guardian of IBM is appliances that we have contact with IBM, but IBM didn't want to collaborate to discover this kind of product by BMC Discover. And we are in a loop, because if I know the content, I can collaborate in create a ticket and to collaborate only with BMC to discover the product. But if I don't know exactly the content, it's complicated for me to collaborate in this kind of discover.
Yeah, well, it's one of those things that there is an API, I think, for this particular device, and that's how we'd have to build a plugin that knows how to deal with these particular kind of devices, and that's really the only way to deal with the different ones.
In this case, if you have not put in a request, so you can make a request for enhancement, that and knowledge update team, the TKU team, they spend a lot of their time doing this kind of job. And obviously that has to be a prioritization exercise in terms of which things do they work on versus which ones have to wait. But if you have not done so already, then you should put in a request for support for these devices. That obviously, if you'd been able to figure it out yourself, that would be a big leg up to helping that. But if you're just saying, okay, I'm trying to discover these devices, put in a ticket to say, please support it. There's no guarantee that we would be able to, but at least if you put that on, it can be considered by that team.
Thank you.
Thank you, Jose. Next question that we've got in the Q&A is from Saga. Is it mandatory to have all the software identification done before modeling BAI?
Well, maybe I'll answer that, and it relates to a question that someone else asked. I think it's an anonymous person that Matt answered in the chat about candidate software instances. So again, to set the stage, when Discovery scans it, if it's scanning a host, so a Linux server or a Windows server or some ancient Solaris or AX, whatever, it tries to identify the software. And we have a big library of patterns in our TKU that identify lots of off-the-shelf software. And obviously there are off-the-shelf products that we don't identify. We can't identify everything, but we do have very good coverage. But then also many organizations, many of our customers, they have their own bespoke software that they wrote themselves or was written on their behalf. And so obviously our knowledge update does not know about any of this custom software. So the question, well, the two questions, first of all, of it, when Discovery scans, if it sees some software executing that it does not know what it is, but it looks interesting based on various heuristics and rules, then it will create a thing called a candidate software instance, because it says, here's a piece of executing software that looks like it's probably doing something interesting. And that's basically based on knowledge about how things communicate. So it can see, okay, here's a piece of software, it's communicating with a thing running on another host. Well, maybe that's of interest to you. But there's a big important part of the maybe, in that it doesn't know, because, well, by definition, it doesn't know what this thing is. And so it might be the case that you want to take some of these candidate software instances and teach the system what they are, and then they become actual software instances. So you basically give it a type, and that allows the system now to say, okay, here's a software instance. And why might you want to do that? Well, you might want to do that just for its own sake, because you want to identify this piece of software because it's meaningful to you, and you just want to be able to look at it and say, okay, where is my customer thing X, where is it running? Well, if you teach the system how to identify it, then it will do that for you. And that there's features in the product that let you do that, either via the user interface for simple things or writing your own patterns in TPL for more complicated things. So you might want to do that just for its own sake. But one of the specific reasons why you might want to do that is because it's important for a service model or an application model. And so part of the flow of modeling an application or a service is you might wish to identify what the candidate software instances are such that they can become part of your service models. And this is why it's related to the answer of what Sagar's asking. So again, should you do that? Well, actually, I say the default answer is no. Don't go on a big crusade to get rid of candidate software instances, because a lot of them, there's no reason to. That only do it if there's actually a clear value to you in doing it. And the value is not, oh, I've reduced the size of the list of candidate software instances. It's got to be, I'm benefiting from this data somehow. So should I identify all of the software that goes in an application? Well, it would make your application models slightly more precise if you do. But maybe it'll be good enough if you don't. So if you build a service model using, or an application model using SAM that involves some candidate software instances, the candidate software instances are kind of excluded from it in the sense that they are not part of the model, because by definition, the system doesn't know what they are. But they are still relevant to finding the things that are related to each other in your service. So if you just ignore the candidate software instances, basically say, okay, they're there, I don't care, then much of what you get from service modeling will still work. But it will be slightly less precise a model than if you have modeled and identified all the software. So that's a very roundabout way of saying that So is it mandatory to have all the software identification done, is the question. No, it's not. Is it helpful to do that? Well, often yes, but it's a matter of return on investment, in the sense that if you spend weeks and weeks getting rid of all your candidate software instances, and that saves you 1 day's worth of time in understanding the contents of an application, well, that wasn't a very good cost-benefit trade-off. If, on the other hand, you're saying, okay, this thing is really important to me, I'm going to model that as a software instance, well, that probably is worth the cost-benefit trade-off. So there's no simple single answer. But I would err on the side of not doing it. Only do it if you can see there's a value in doing it. Did that answer the question from Sagar?
Yep. Thank you.
A quick question on that. I think, Andy, you wanted to just take the previous question, which came from Victor, but did you want to add anything to that as well?
Duncan basically covered
covered.
It's covered.
Okay.
So I think we've covered all of the currently open questions. I can share my screen again, and we can go to the. Oh.
As soon as we say that, another question comes up.
Appears.
Okay,
well,
that's an excellent question. I'll answer that question, which is, if I have to start service modeling from scratch, should I go with SAM or blueprints? And I'm going to answer in a very facetious way and say yes. Yes, you should model with either SAM or blueprints. And the reason it sounds stupid, but it's not stupid, in the sense that they do different and complementary things, in the sense that if you have a very fixed, rigid shape of your service, and a good classic example is this, is I'm deploying some things into Kubernetes, and I know that everything in namespace ABC is part of my service, then the kind of rules that you define with blueprints works extremely well, and it makes it easy to identify many, many instances of services that are all the same basic shape, because a blueprint is about telling the system, this is the shape, this is how things are related together. And if you have lots of services, all of which are the same shape, then that works very well. What SAM is trying to do is kind of exactly the opposite. It's trying to handle the weird and wonderful vagaries of how different services are put together, and in circumstances where you, the end user, might not even know how they're put together. Because to know how a service is put together, you actually need to know two things, which often you don't know. The first thing you need to know is, how in the world is my service put together? In that, what bits of software are there? What databases does it use? What are the components? What are the load balancers set up? And there's a good chance that you, as the discovery user trying to build a service model, do not know the answer to those questions. Even if you do know the answer to those questions, you also need to know that's how it is in the world. How does that get reflected in Discovery's data model in terms of what Discovery has been able to discover? And you probably also don't know that. So you have to spend a whole load of time exploring in order to find that out. And that is the kind of circumstance that SAM is designed for, which is that it uses its knowledge and its heuristics and its rules to automatically try and find the things that are most likely to belong together in your service in a very flexible way. And if your service changes shape, so that you used to have a simple service that's using one database and now it's grown another database, it will automatically find that other database. And if it used to be a thing with a simple web front end and now there's a load balancer in front of the web front end, it will automatically add that to it later when the system changes, which is not at all what would happen with blueprints, because blueprints, you bake into it the shape. So which should you use? Well, it depends on the nature of the service. And how would you choose? Well, a way to choose, at least, is to go and look in Discovery at a visualization and try and find your service. And if you see the visualization finds most of the things you think are part of your service and not too many things you think are not part of your service, that is a sign that SAM is going to work very well. If, on the other hand, you don't find all the bits, or actually more often you find way too many things, then that's a sign that maybe SAM, at least currently, is not going to do a good job for you. Because as soon as you say, oh, well, this SAM model will be perfect, I just need to keep these 10 things and remove these 1,000 things that I didn't want, that's a sign it's probably not going to work well. And as I say, conversely, blueprints, if you can tell me up front, my service always contains exactly this thing related to this thing, related to that thing, related to that thing, then you can easily define a blueprint that will find those things. But it depends very much on the nature of the service, which will be best.
I've marked the question as answered, but does that answer the question as question? It's an anonymous attendee, so I don't know who to refer it to. Will Anonymous please stand up? Okay, maybe I should share my screen and we can look at some of the questions in the later slide and see if that, but, oh, hang on. There we go. Just by talking about it, another question appears.
Hello, Dave. Can you hear us if you want to come off mute?
Yep, I can hear you. So questions about SWID tags, kind of a standard for recording metadata about the software and where it's installed. And we use a lot of that for homegrown applications. And it's also a COTS type thing, right? So I guess the question is, I mean, unfortunately, they're installed everywhere, right? So it could be, it's more like a file scan than it is true discovery scan. So is there anyone, I guess, or have you guys come across where people are using SWIDs and trying to embed that data about the software? It helps with modeling, right? And finding out that this software is part of a bigger piece of software or version control or that kind of stuff.
Well, it's a good question. So do we today do anything automatically with this? I'm sure you know the answer is no, we don't. This is something that a few years ago, probably, I don't know, it feels like about 5 years ago, it was kind of a hot topic, and we did spend some time looking at this, and then it kind of went away in the sense that the industry was very enthusiastic about SWID tags, and then, at least recently, I haven't heard anything about SWID tags at all. But sometimes, clearly, they are of value to what Discovery can do, and there certainly are customers who, like you said, they use them for their own custom software, and I believe there are customers who are using Discovery to collect that information. But do we currently do it out of the box? No, we don't. And I haven't heard, but I don't think we collectively have heard there being a significant demand from that across the industry. But if they're coming back into precedence, then yeah, again, it's a thing that could be put in as a request. That we can't make any promises, but it's an interesting area to.
And Dave, it'd be worthwhile, maybe we can follow up with you if you're open to that, via product management and others, to have a follow-up conversation about that, and we can do some further research about other customers who may be having similar requirements.
Sure. Yeah. Thanks, guys. Yeah, and I get it. It's one of those probably oddball things, but it does seem to be the direction that we're moving in, to identify homegrown software and embed some of that data ownership and some of the things that are challenging. And if we can deploy it via repos or whatever, it makes it really easy to make sure that data kind of follows along with the software.
It's an interesting topic, and certainly something we can talk about.
Awesome. Thanks.
I don't know whether this is an option for you, and shoot me down if necessary, but obviously that it is common and for customers to write their own custom tipple patterns. I'm not sure whether that approach has been considered at where you're working, to see whether this could, if you need that information, maybe you could get Discovery to get it for you. But I'm basing that on no knowledge of how SWIDs work, so that may be a bad piece of advice.
Yeah, essentially, it's a fancy XML file, and we do have some custom tipple now, but the advantage now is we've kind of forced them to putting all those XML files in one folder. New World is, as the software is getting deployed, it rides along with wherever that software gets installed. So I guess you'd have to write some tipple, and undiscovered software becomes interesting because, like you said, it's candidate, and now you have to find what makes up that candidate software so you can discover it, to write the tipple, to find the SWID, to add the data. So it just becomes kind of a, that spider web. Now, I know there's another company that does software ID tagging discovery, but it's more of that deep file level discovery, not so much at the what Helix is doing.
Understood. Thanks for the question.
Yeah, I mean, definitely what we focus on is executing software, and we're not in the business of finding everything that's installed, and that's not an unreasonable thing to want to know, but that's not what our product is trying to achieve. Sure. But yes, that doesn't mean that SWID tags are not relevant. They're just not as relevant. If you're just searching for any software at all that's available, then the SWID tags are probably extremely valuable. Less so for what Discovery does, but they could still be pertinent.
Thank you.
Thank you. I'm going to share my screen now, Sam, just in case there's got 5 minutes left though, and so we'll see how far we get through. Start sharing again, and this time it didn't prompt a question to appear. So maybe we can look at the. So there's there's a selection of questions that came through before the meeting. I don't know whether any of the panelists would like to take a particular one from this collection. So we can't talk about futures necessarily.
Well, so in the absence of anyone piping up, it's potentially a good opportunity to talk about. So the second question and similar, it's kind of the answer affects some of these is why do. Well, the question is, why do model definitions and business application instances hold different numbers of CIs? Well, they don't, is the simple answer, but it is potentially worth talking about how the definition of service models and application models work in Discovery and the consequences of that. So, well, first of all, to avoid confusion, we generally don't talk about CIs in Discovery. CI is a CMDB term. We feel it's confusing. I feel it's confusing because you tend to use CI to refer to the thing in the world, as in its configuration item in the world, and also the data that's stored in your database in the case of the CMDB, and that gets confusing. So in Discovery, we tend to talk about a node, meaning that's the thing that's stored in our database. But anyway, that aside, all of the modern approaches for making application models and service models, you have two things that reflect the service model. There's a thing called a model definition, which, as the name suggests, it encapsulates the definition of the model. And then you have a thing that we say is published from that, which is either a business application instance or a technical service or a business service. So why do we have these two things? Well, it's because the business service or the business application instance, that represents the thing of meaning in the world that is the actual service or the actual application. Whereas the model definition, that encapsulates how Discovery knows that that thing exists and how it's going to keep it up to date. So in a SAM service model, the model definition, it remembers all of the nodes that are included in the model and also all of the nodes that are not included in the model that you've explicitly removed from the model, and some other metadata about why are they in the model that it uses to maintain the service model. With a blueprint-based service model, the model definition encapsulates the actual blueprint, the rules about what are the nodes and relationships that should be in the model. So the model definition is an encapsulation of what's in the model, but why is it in the model? Whereas the business service or the business application represents the thing that's constructed from the model. Now, the question is, why do they hold different numbers of nodes? I'll say, well, they don't really. The thing is that a model definition, it is a node and it has relationships to every single node that is included in the model. So if I've got a service that contains, for example, a load balancer front-end service and some load balancer members and some software instances and some databases, every single one of those nodes will have a direct relationship to the model definition to say all of them are in the model. And that's true whether it's a SAM service model or a blueprint service model. All of them are like that. But then from that, I would publish, for example, a business service. Now, the business service, it's one of the main reasons for that to exist is to understand how things impact each other. And so in this example where I've got a business service that has a load balancer in it, well, if you think of an impact chain as being drawn vertically, the things at the top are the things that are impacted by the things below. And so the load balancer service is at the top and everything else impacts the load balancer service. And then partway down, you'll meet the software, and partway down, you'll meet the hosts, and partway down, further down, you'll meet the network infrastructure if you include that in your model. But the thing at the top of the impact chain would be the load balancer service. And the representation we have in Discovery is that only the load balancer service would at the top would be related to the business service, because that allows you to answer questions of how do things impact my service, and that will they all impact it via that thing at the top. And so this can lead to the confusing view that you've got a different number of things directly related, but it's not because it's reflecting a different number of things in total in there. It's that one view is giving you a structural view of how things impact each other. The other one is giving you a very flat view of just what are all the things in the model. I don't know if that answered the question from whoever asked the question.
It's a good topic, and a good question. Given we've spoken about modeling before, I think it's a good one to round that topic out, and it's one that we've seen come up a few times. I'm looking at the time. It's now top of the hour. I think, Sam, that means that we are out of time.
We are. There isn't any further questions that have come into the live Q&A. So what we will do is get the final questions answered, and we will post out the recording in the next 24 to 48 hours. If you do have any further questions that you want answered, the link that was shared out with you to sign up, there is a community page. I will again also put that in the thank you email. If you want to put other questions in there, we'll reach out to the team. Hopefully that's been useful for you. Final call to action is we work very closely with our customer advocacy team. They're looking for some feedback for BHOM, AIOps and Discovery. So if you do want to scan this QR code and put some feedback in for our Gartner study, there is a $25 gift card. Obviously, it will be equivalent to wherever you are located because not everyone's US based. And there's also a link that I will share with these slides. So we will be sending these out. Thank you also to our panelists. Lots of great questions. Most of them you will recognise. They will be joining for webinars coming up with future stuff. Anything we also want to share from a development perspective. So do spend a few minutes filling in the survey as well. Let us know if there's anything else you want to cover. I have very willing panelists that are quite happy to do some webinars as well. And thank you again for everyone's time.